All right, so again, what we had was this situation where we made this argument about increasing the number of rectangles to infinity um, and evaluating that sum delta x, sum from 1 to n of f of a plus I times delta x. Okay? And what we said was that this was, when we make that argument, when we actually evaluate it for n going to infinity, we get our definite integral, this thing, this f of x dx. Okay, and we have rules depending on the different kind of function for how to evaluate this. But for the most part, we're going to use the machine, so I'm just going to continue with that example here. So we were doing this using SymPy, where we had symbols and doing symbolic integration. So first we declared a variable as a symbol. So this is going to be psi dot symbol x. Okay, I still have my function defined from earlier. Okay, I still have my x squared plus 1 defined here. So I just had to change what x was to a symbol, and now I can go ahead and evaluate the exact area as just the integrate f of x in terms of x from 0 to 2. And I get the exact area as 14 over 3. So let's see how our approximation error, because before we had found with 4 rectangles the total area was 5 3/4. So we have the difference between the exact area and the total area, and okay, so we were about a whole 1 off, which is significant considering the size of the total area. But remember, this is how we would find the exact value, is by evaluating the definite integral. And similarly, what we could do is we could have an area that's defined by a boundary between 2 curves. So if I have another function, g of x, maybe this one is negative x squared minus 3. And let's take a look at how this looks with f of x and g of x together. And what's happening here is I forgot to change x back to a number. We care about it from 0 to 2. And okay, so maybe I want to find the area between these 2 curves. So now what I'm doing is I'm defining the height of my rectangle as the difference, the height of f minus the height at g. So if we want to actually evaluate that, again, we'll change back to symbols here. So change back to my symbol. And now instead, I'll ask it to integrate f of x minus g of x in terms of x from 0 to 2, and we get a different value, okay, of 40 over 3. So that's kind of our 2 steps. First, we're just finding the area beneath the curve, and then we're finding the area between 2 curves, where the height is defined as the difference between them.